Hello everyone, I'm Huixiang Luo from Alibaba Health. Today I'm excited to share our work, Knowledge-Informed Bidding with Stereo Process Control for Online Advertising. Here's the outline. I will start with the motivation and problem formulation, then walk through the KBD framework, followed by our experiments and results, a few reviewer QA highlights, and the conclusion. Let's start with the motivation. Auto bidding now dominates digital advertising with over $200 billion in spend projected for 2026. Advertisers set high-level goals like target ROI or target CPA, and the platform handles per-impression bidding decisions. The mainstream approach falls into three categories: rule-based methods like RTB control, reinforcement learning methods like USCB, and generative models like DivBid. However, pure black box and machine learning methods suffers from poor generalization in data-sparse cases, myopic single-step optimization, and fragility under distribution shifts. Our approach, KBD, embeds human expertise into a dual process framework that combines global sequential optimization with robust reactive control. Formally, we consider bid optimization under GSP auctions with target CPA auto-bidding. The objective is to maximize expected conversion value subject to budget and cost constraints. Under the MPID framework, the optimal bid decomposes into a linear function of the advertiser's control parameter C. This C is the only lever the advertiser can adjust. Our key insight is to decompose C into two components: a day-level-based TCPA produced by iFormer and an hourly adjustment coefficient from the DT plus PID dual process controller. This two-stage decomposition separates strategic planning from tactical execution. Now let me walk through the KBD framework. Here's the overall architecture. The blue blocks represent neural network components. These are the black box data-driven parts. The yellow blocks are rule-based and interpretable. And other blocks are where the two fuse together. The macro stage runs daily to set the base bid, while the micro stage adjusts hourly. At the macro stage, we introduce iFormer, which injects expert knowledge at three levels. At the hypothesis level, we use a transformer encoder for feature extraction, coupled with a symbolic price volume interpreter that outputs TCP as price times weight. Isotonic embedding ensures monotonicity, and the GRA provides entropy-driven partitioning. At the algorithm level, we enforce three expert priors: monotonicity, the soft plus activation; smoothness, the penalty on sharp weight transitions; and diminishing returns, the air margin constraint. At the data level, we enable cross-strategy transfer using target ROI and target CPC campaigns to augment target CPA training samples, which helps mitigate data scarcity. At the micro stage, we adopt a dual process design inspired by Carmen's System 1 and System 2. System 2 is a decision transformer that models the 24-step daily MDP. It takes campaign features as state and outputs a multiplicative bid coefficient between 0.8 and 1.2. It optimizes long horizon cumulative return. System 1 is a PID controller, rule-based, deterministic, and low latency. It reacts to spend rate deviations in real time. The fusion mechanism uses MAPE as an uncertainty proxy. When the DT is uncertain, control gravely shifts to the PID. During training, we add an MDL regularization term that encourages the DT to learn from the PID's expert guidance. Let's move to experiments. We evaluate on two datasets, iPinyo, a public benchmark with target CPC click maximization, and ECA, our private platform with 200 advertisers running target CPA and target ROI campaigns. We compare against 7 SOTA baselines on iPinyo and 7 on ECA. Our evaluation addresses 4 research questions covering overall performance, IML ablation, robustness, and the dual process effect. On the iPinyo dataset, KBD achieves the best R over R star of 0.73 and the constraint satisfaction of 82.78%, outperforming all baselines. The ablation shows that removing DT costs 0.7% in R over R star, while removing PID costs 2.5% in constraint satisfaction, confirming that both components are essential. For online evaluation on the ECA platform, we ran 3 test periods from September to December 2025. iFormer alone already achieves plus 8.4% in cost exhaustion and plus 6.1% in GMB. With the 4 KBD including the DT, the lifts reach plus 14.6% and plus 13% respectively. The bottom right picture shows how our margin prevents overfitting in the learned price volume curves. For Q2, the IMAIR ablation on ECA shows that each component, isotonic embedding, GRA, air margin, and cross-strategy transfer, contributes to reducing weighted MAP. For Q3, the segment number N is robust across 6 to 15 with WMAP consistently between 21 and 27%. Q4 confirms that the dual process fusion yields roughly 1% gain on both metrics compared to either component alone. Let me address a common question. Is the DT just doing behavior cloning? The answer is nuanced. We trained the DT on carefully curated high-quality treasuries from the past 30 days, specifically campaigns with duration at least 12 hours, cost exhaustion ratio above 0.9, and ROI ranking in the top 50% within the same budget tier. So it's expert demonstration learning from near-optimal policies, not random behavior cloning. Another question concerns statistical significance. We use synthetic control method rather than did PSM or DDD because the experiment and control groups have systematic differences that violate the parallel trends assumption. Our SCM pipeline has 3 steps. First, partition campaigns so that treatment and control are balanced on GMB, cost, budget, and count. Second, run an AA test within the control group as a sanity check. Third, verify that the AB lift is statistically significant over the AA baseline. Finally, why don't we report CPA target compliance online? The reason is that merchant set targets are often poorly calibrated, some trivially easy, others particularly unattainable. Using them as metrics would conflate bidding quality with target setting quality. Instead, we use GME lift and cost exhaustion ratio, which directly capture the business impact of bidding decisions. To summarize, KBD introduces a 2-stage bid optimization framework, IFormer for daily-based bidding and DT plus PID for hourly adjustment. The dual process control enables graceful degradation under distribution shifts, which achieves sort of offline results and strong online lifts. Our future direction is LLM-based bidding agents with transparent causal reasoning. Thank you for your attention. I'm happy to take questions.